Hello, class. Back continuing on the idea of definition of angles and a couple applications. So where we left off was talking about the idea of measuring angles in radians. And one last aspect of that is needed is this idea of quadrants, excuse me. And the idea of quadrants, just like we talked about it in algebra class, is the idea that there are four quadrants. And the first quadrant starts where both y values and x values are positive. And again, you move around the Cartesian coordinate system counterclockwise to 2, 3, and then quadrant 4 is when both the x values and y values are both negative. And you'll see that when we start defining what a trigonometric function is, like sine, cosine, and tangent, which are by far the three most important, the ideas of knowing where you are in the quadrant will give you a good understanding of what the values of those trig functions will be, i.e., are they positive or are they negative? Again, these ideas with regards to angles. So we'll be talking about that a lot more throughout the next few weeks for sure. But let's take it now to this idea of measurement in degrees. And so this is what I think of. I think of degrees as an application guy and an engineer. I usually don't say, oh, I've moved around a circle pi radians. I usually say I moved around the circle 180 degrees. And so that's kind of how I've always thought with regard to that. And so the good news is a very easy conversion between one and another that we're going to talk about very shortly. So the idea and the definition of a degree, and as you can see here, is a rotation, again, around the circle. And if you go around the circle, say a quarter of the way up to that y-axis that you see there, you see that we've traveled 90 degrees. If you go another quarter or a halfway around, you travel 180, and so on and so forth, all the way till you get back to the x-axis again, all the way around is 360 degrees. So if you think about the idea of the definition of how to relate degrees and radians, if you go all the way around the circle one time, right, it would be 2 pi radians, and that would equal 360 degrees. And that little circle at the top there is a degree sign. Sometimes people will write DEG. Either way is 100% okay. So you can see that if I divide each side by 2 here, right, these will cancel. And you'll see that we get pi equals 180 degrees. And that is the relationship that I use and is defined in here by the book when you talk about converting radians to degrees or vice versa. Usually in real world applications, you'll usually do your calculations in degrees, but because the radian is a dimensionless quantity, you usually have to plug in radians to do a lot of types of calculations that we'll talk about at the end of this section. Let me get back to presentation there and move on to the idea that we just talked about. And so if you take a look at these conversion factors, you can see that these kind of the relationship. So I think what you really want to just kind of put in the back of your mind here is that 180 degrees equals pi radians. And with that, depending on how you want to convert going back and forth, it depends on, you'll see what you put, say, in the denominator or in the numerator. And so let me show you a couple of these on the whiteboard. I think that would be better. Okay. So say like we had the question that you're given 135 degrees, and this is typically the idea, and you want to convert it into radians. So the strategy is again, we have 180 degrees equals pi. And remember, you could divide and get a ratio of the 180 degrees could be on the top and the pi could be on the bottom. So if I divide each side by pi, right, you get 1 equals 180 degrees over pi, right? Or you could flip it, right? If I took that same equation, right, and divided each side by 180 degrees, all right, you can see that goes to 1, and now we have radians on the top and degrees on the bottom. And so the strategy typically is that you want to cancel units, right? And so if you want to go from degrees to radians, you'll want this conversion factor. And you could see that you can multiply any number by the number 1 and you're not changing it. So that's what we mean by this ratio, that when you multiply it, it'll convert it with regards to degrees back to radians. So if you think about this, we could set it up this way, right? And so when we do that conversion factor, you could see that the degrees cancel, right? So now we're stuck with 135 over 180, all right? And then times pi. And I will warn you right now, one of the things that you're going to have to get semi-familiar with is manipulations of fractions. And the idea of manipulating a fraction, I actually got pretty good at when I started working as an electrical engineer with my mechanical engineering friends. Because in the US, all these dimensions are always in fractions. You have a quarter, an eighth, a 16th, a 32nd, a 64th. And so they could manipulate fractions in their head so fast. Kind of annoyed me, so I actually got pretty good at it as well when we were in our design review meetings. So I could definitely stay caught up with them with regards to that. So let me show you the strategy that I would use in taking this 135 over 180 and reducing it to the lowest common denominator fraction idea. So let's take a look at the idea of 135. So what kind of factors will go into 135? Well, right away, you could see that the number ends in 5, right? So 5 is a factor of 135. So if you take 5 out and you divide that into 135, you would get 135 times 27. And if you don't see that, just take your calculator out and do it, and away you would go. So and so now we know that 27 is what? 27 would be 9 times, or I'm sorry, yeah, it was 9 times 3. So now we have the factors. And now if you think about it, what are the factors of 180? Well, 180 is a really nice number. And so you can see that it ends in 0. So we know we have a factor of 5, right? So that would be 5. And then if you got your calculator out, you would see that would be 36. And you see we have that factor of 9 there. So we could do 5 times 9 times 4. So you could see that these would cancel, the 2 5s. The 9s would cancel. And so you would end up with 3 on the top, what's left there, 4 on the bottom, what's left for 180 times pi. So when I sit here and do these conversions, this is how I would manipulate those fractions. You'll see that you're going to be doing this a lot. So you're going to have to kind of, get a feel for how to do that in manipulating fractions. And you'll see that when you do the homework and and WebAssign through Brightspace, when you do these conversions, they're going to ask you to put it in fractional form, not decimal form. So just a little warning with regards to that. So practice that a little bit. I think that'll be an important aspect of it. And as we continue through some of these lectures, I'll also walk through some more examples with regards to that. Okay, so let's take a look at a couple examples of going from radians to degrees. And so what we have here is the first one is converting 7 pi over 6 radians into degrees. So let's actually do both of these on the whiteboard. So with regards to doing these conversions, we have 7 pi over 6. And now we want to convert it into degrees. So how do we do that? Well, you want degrees on the top, all right? And you want the radians on the bottom. And typically you don't write out radians, but we can in this case, right? Because this is radians down here, and this is radians over here. And so you could see that the radians cancel, and that's kind of nice. You could see the pi's cancel, so in this calculation, that's kind of nice. And then the way I would do it is you can get your calculator out, but you could see 6 goes into 180 30 times, right? And so what's left is 7 times 30, which is 210 degrees. So those are the ways that I would kind of walk through those calculations with regards to that. So next one, for example, say like we had minus 3 pi over 2, and we want to convert that to radians. Remember that what that would be meaning is that you're going in this direction now, the counterclockwise direction. And actually, if you go all the way around, you'll see that we'll end up right here. So this would be minus 3 pi over 2. And what is that going to be in degrees? Well, let me show you. It should be minus 270 because we've gone around 3/4 of a way in the clockwise direction, which gives us negative. Remember, negative only gives you the direction with regards to that. So again, we're going to do 180 degrees divided by pi. So that idea is that we have pi and pi cancels. We have the 2 goes into 180 90 times. And so 90 times minus 3 is minus 270 degrees. So that means this would be minus 90 going that way. This would be a minus 180 going that way. And this would be minus 270 going that way. Again, here's where a place where I'd say, are there any questions? But again, it doesn't make any sense in this format. So the last thing we're going to talk about and the definition of angles, and then we're going to do some applications, is this idea of a coterminal angle. Again, in real world application, I have to admit I've never used this, but you'll see that there are a few places in the book and / in the homework where we talk about it. And it does have a place theoretical, not really practicality-wise. But there are some very practical aspects of trig, which we'll talk about. So this idea of a coterminal angle is that if you take two angles, and you can see here we have pi over 6 and 13 pi over 6, and what we call that is their coterminal, is that you can see the difference between the two is 2 pi. And they say that this idea of two angles being the difference is 2 pi is coterminal. And you can see that by those two, I guess, diagrams that we have here on the lower right-hand side. And so when you take a look and you want to prove this idea, as you can see here, is that if you take a look at this 13 pi over 6, and you subtract 2 pi over, you end up with pi over 6. So again, in the grand scheme of things, this is not super important, but there is, like I said, a couple definitions that we use later on that uses this coterminal angle. But the idea that I want you to understand is how to calculate them. And so let me do a couple of examples here. So the first one is the measurement of an angle in the standard position is given. Find two positive angles and two negative angles that are coterminal to the given angle, which is, in this case, 45 degrees. So let me kind of do this on the whiteboard here. So the idea here is that we're trying to find this angle, and 45 degrees is right in the middle right here. This would be 45 degrees. And the idea is that you want to find two positive angles and then two negative angles that are coterminal with the given angle. And so the idea of getting these angles is that, remember we had the equation that looked like 2 pi times n, right? Well, remember 2 pi is radians. We could also define it this way. 360 degrees times n, right? Because these two are synonymous with one another. So what do you do with the first one? Well, you calculate the first positive one is n equals 1. So that would be 45 plus 360 times 1. And so that would be 405 degrees. And a good check would be as you take this angle and this angle and subtract the two, you're going to get a multiple of 360. So that would be the first angle that's positive. What would be the second angle that's positive? So that would be 45 plus 360 times 2. So what is 360 times 2? That would be 720. So when you add those together, you would get 765 degrees. So that would be the two positive ones with regards to that calculation that we have right up here. And so the next one would be the two negative calculations. And you can see that it's the same idea with regards to that. Maybe it's better if I do it on the whiteboard. So let me take a look at that one again. I should have just finished it on the whiteboard. Sorry about that. So the same idea is now we want to go negative. So instead of adding, you have this equation. Whoops. I do have an eraser on here. There we go. So instead of adding, you subtract 360 times n. So when n equals 1, you would get 45 minus 360. And so that would be minus 315 degrees. And then the second one would be n equals 2. And so that would be 45 minus 360 times 2. And when you multiply that together, again, you get minus 720. And then when you add those two together, you would get minus 675 degrees. So again, in the grand scheme of trig, not super an important concept, but hopefully it's not too complicated. The idea of taking two angles And either the difference between the two angles always is a multiple of 360. It could be plus 360 times the value of n. So it could be 360, 720, 1080, or you can go the other direction. It'd be minus 360, minus 720, et cetera, et cetera. So let's see where we're at here in these calculations. So I'm just going to show you these right here on the slides. So instead of doing degrees, we do radians, and pi over 4 is 45 degrees. And so you can see if when n equals 1, we add 2 pi. And remember the common denominator would be 4, so it'd be 8 pi plus 1 pi divided by 4 is 9 pi. And then when n equals 2, 2 pi times 2 is 4 pi, and you see you could add it that way. And then when we do it on the negative side, you're just going in a different direction. So instead of adding 2 pi and 4 pi, you subtract 2 pi and 4 pi. So the other idea is that given two angles, are they coterminal or aren't they? So how do you determine that? Well, the idea in this case is that is the difference a multiple of plus or minus 360. And so what do we mean by that in the difference part of it? Well, if you take a look here, I'll show you on the whiteboard here real quick. So if you take these two numbers, right, you would have 210 and 150 degrees. So what do we mean by the difference? Well, what we mean when we say the difference is that you have to take one number and subtract it from the other. And the good news is it doesn't matter which way you do it. Let me do it both ways to show you what I mean. So the idea is that if you take the minus 210 and you subtract 150, what do we get? Well, here we get minus 360 degrees. And you can see that is a multiple. It's going in the negative direction, but it's still a multiple. Say like we did this, we took 150 and we subtracted a minus 210. What does that give us? Well, you can see that these two minuses give us a plus. So it converts it to 210 degrees. And you can see that gives us positive 360. So the good news is it doesn't matter which way you do it with regard to that. You either get a plus or a minus. And so it does, you don't have to think about it too much. Just pick which way you'd like to do it and see if you have a multiple of 360. And so I'm going to stop here and start the last video of this section shortly. And then we're going to talk about a few applications.